Okay, hello again. In our math tutorials, we're still in the prerequisites for Algebra 1. We were reviewing how to solve equations in different forms and in different uh, terms. Let's see now how to review how to solve a one-step equation in the first example in the warm-up. Please pause the video, try to do it on your own, and come back to check it. What do we have here? We have negative 56 is equal to 7y. It's a one-step equation, as I said earlier. Uh, to undo multiplication by 7, you can only divide here by 7. Negative 56 divided by 7 is negative 8. So y would be equals to negative 8. This example is actually reviewing many old concepts introduced earlier. Try to remember, for example, the formula of finding the area of a parallelogram and simplifying or dividing decimals. Let's see what do we have here. We have a parallelogram with base 3.4 centimeter and the height is unknown, and it's required to find the height of this parallelogram. First of all, to recall the area of a parallelogram, it is the height times the base. The base is given and the height is unknown, and also the area is given. So I can rewrite this using the value of the area. If the area is given 7.82 equals to the height times the unknown height, which I need to find, times the base 3.4. Now I have an equation. It includes only one variable, which is unknown, the height. 7.82, the area, equals the height, times the base 3.4. To isolate the height and get its value, I would divide both sides by 3.4 or divide here directly by 3.4. Using long division, you would find out that the height would be equals to 2.3. And this one, the last one in this quick review, it's a multi-step equation. P over negative 3 plus 51 is equal to 37. Again, an equation includes division and addition, the backpack on your shoulder, and the shopping bag in your hands. Which one to start with? Exactly as you might guess correctly, we would drag the 51 to this side first with the opposite sign. So it is P over negative 3 equals 37 minus 51, which is negative 14. Now, you might consider using cross multiplication as introduced earlier to isolate the P. P times 1 is P. Negative 3 times negative 14 is positive 42. Now let's see the objective of this tutorial. As you know, we were reviewing the multi-step equation, how to solve multi-step equations. Today we're going to see how to solve equations with variables on both sides and involving grouping symbols like brackets. Let's see the first example. 8 plus 5c is equal to 7c minus 2. The main key or the key concept of solving equations with variables on each side is to put all the variables on one side and all the numbers in the other side. Again, as we know, the equation has a right-hand side and a left-hand side. So to solve any equation involves variables on both sides or in each side is to put all the variables on one side and all the numbers in the other side. And a tip you might consider to use, you always drag the least coefficient to the larger coefficient in order to avoid having any negative signs. I have here 5C and 7C. As I said, I will put all the variables on one side and the numbers in the other side. So I'm going to start by dragging this 5C to the 7C, and this -2 will be taken to the other side, to the left-hand side with the opposite sign. Let's see how. Here is the equation. As I said, I will drag this 5C here, so it will be 7C minus 5C. And after taking the 5C from here, I still have the 8. I would bring the 2, the -2 with the opposite sign will be plus 2. Now in one step, I put both the C's on the right hand side and both the numbers 8 and 2 on the other hand side. 7C minus 5C is 2C, 8 plus 2 is 10. So in one step, by dragging all the variables on one side and the numbers in the other side, I have a very simple one-step equation. 2 times C. To undo multiplying by 2, I would divide here by 2. So C will be 10 divided by 2, which is 5. Let's see the next example. It's your turn now. Pause the video. Again, follow the steps. Put all the variables on one side, the numbers in the other side, and then start isolating the variable. Let's see, what do we have? We have 9F minus 6 equals 3F plus 7. I have two F's here, one on the left-hand side and the other on the right-hand side. As I told you, the golden tip, always drag the least coefficient, the smaller coefficient, to the larger coefficient. I have 3F here, so I would drag the 3F to the left-hand side. I would leave the 9F as it is, bring the 3F with the opposite sign, so it would be negative 3F. After taking the 3F from here, I still have the 7. I'm taking the negative 6 with the opposite sign. So again, in one step, I made all the variables on the left-hand side, all the numbers in the other side. 9F minus 3F is 6F. 7 plus 6 is 13. Again, a single step equation, very simple one. You can divide here by 6 to get rid of this 6. So F would be 13 divided by 6, and it can be written because, as you can see here, the answers, many of them are given as mixed number. So you might see this 13 can be written as 12 over 6 plus 1 over 6. The 12 is rewritten, the 13, sorry, is rewritten as 12 plus 1. So 13 over 6 is 12 over 6 and 1 over 6. 12 over 6 can be simplified into 2, and I still have the 1 over 6. So it's 2 plus 1 over 6, which is 2, and 1 over 6. The answer is C. Now, having equations with both variables on both sides, and including grouping symbols like brackets. This is actually reviewing the distributive property, which was introduced in the beginning of those tutorials this trimester. We introduced, or we reviewed, the distributive property, multiplying one term by a sum or a difference between brackets. So now I'm going to use this property, the distributive property, to multiply the 1/3 by each number between the brackets. And again, I'm doing the same thing here with the 6. It will be multiplied by both terms between the brackets. 1/3 of 18 is actually like multiplying 1 over 3 by 18. So 1/3 of the 18 is exactly like 18 divided by 3, which is 6. And 1/3 of the 12, 1/3 of the 12 is exactly like dividing 12 by 3, which is 4Q, is equal to. Let's multiply now the 6. 6 divided by 2, multiplied by 2 is 12Q. 6 multiplied by the 7 is 42. So I have 6 plus 4Q equals to 12Q minus 42. Again, the tip is to put all the variables, Let me use another color. All the variables like 12Q and 4Q in one side, and you always drag the smaller coefficient to the bigger coefficient. So I drag the 4K with the opposite sign to the 12Q. Why do I do this step? To avoid having negative signs with the variable. 12Q minus 4Q, and now after taking the 4Q I still have the 6. I will drag the 49 with the opposite sign. So by dragging the 4Q to the right hand side, 12Q minus 4Q is 8Q, and by dragging the negative 42 to the left hand side, it is 6 plus 42, which is 48. Now to get rid of the 8, divide by 8, and Q would be totally isolated. 48 divided by 8 is 6. And now I got the value of Q. And as in the question, you can always check your solution. How do I check my solution? By replacing the Q in the original equation. You can always check your answer by substituting the variable by the value I got in the original equation. It is 3 times 18 plus 12 times 6, and you ask yourself, is it equal to 6 times 2 times 6 minus 7? And when you simplify, you would find that the two sides are equal, and you may make sure that your answer is correct. You can always check your answer, and this is the beauty of solving equation. Whenever you're done and you reach your answer, you just replace it or plug it in the original given equation, and you make sure that your answer is correct. Now, from the title, we're solving the same type of equation involving grouping symbols, but we have a different title here, like find special solution. Let me first introduce those special solutions in such cases. If you're solving such equations and you end up with two numbers on the two sides which are completely not equal, like 5 is not equal to -1, or you might find that 13 equals to 0, and they can never be equal. In case of you ended up with two sides are totally not equal, this means this equation has no solution. And if you were in the middle of the equation and you're simplifying, and you end up with, for example, two identical equation on both sides, like 2x plus 3 is equal to 2x plus 3, or you found yourself ended with two equals number, like -11 is equal to -1 is equal to -1. If you're simplifying an equation and you found out that the two sides are exactly identical, you can say this equation has infinitely many solutions. You can say that this equation has infinitely many solutions, which means it's true for all the values of x. So those are the two special solutions we have. Either to have two sides which are completely not equal, like those two, you're ending up with two numbers will never be equal, so you say it's no solution, this is the first case. Or you ended up with two identical sides, two exact the same numbers on both sides, -1 and -1, 15 and 15, the two equations exactly on both sides, 2x plus 3 is equal to 2x plus 3. So in this case you say it has infinitely many solutions. It means all real numbers are solutions. It means all real numbers are solutions, and this is the second case. Let's see, the first example here represents which cases of those special solutions. Again, I will start by using distributive property. 8 times 5 is 40c. 8 times -2 is -16 equals 10 times 32 is 320. 10 times 4c is 40c. We drag all the variables on one side, as you know. So I'm dragging this 40c to this 40c. You might observe now that those 2c is 40c minus 40c will be 0, and 320 plus 16, I'm dragging the 16 to this side with positive sign. So 40c minus 40c is 0. 320 minus 16 is 336. Those two sides will never be equal. So the solution here is no solution. It means there is no real number would replace c to make this equation true. Again, when you find out that the two sides of the equation are impossible to be equal, you say no solution, and no solution here means there is no such a number, there is no real number would replace c to make this equation true. We can never find a value for c would make this equation true. Let's see the next example, and again we have another special solution. We will start again by using distributive property. 40 plus 4 times 20 is 80. 1/5 of the 20, it means 20 divided by 5, which is 40. 1/5 of 400, 400 divided by 5 is 80. Before going any further, before simplifying any further, you can see that the two sides are exactly identical. 40 plus 80 is equal 40 plus 80. As we introduced earlier, when both sides are exactly identical, when you have the right hand side is exactly equal to the left hand side, you say this equation has infinitely many solutions. It means it is true for all the values. You can say all real numbers are solution. What does it mean? It means all the numbers, when you replace t by any real number, the equation will remain true. All real numbers can make this equation true. It has infinitely many solutions. It means it is true for all the values of t. It is true for all values of t. All the real numbers can make this equation true. Thank you for listening to this tutorial, and until we meet again, keep safe, please. See you.